What does a router look like? Well, it's just a metal box. That's really what it is. And that metal box is going to have various components inside of it. A CPU. What's the CPU for? Processing. That's right. Processing information. It might be processing commands that you are telling it to execute. It might be processing routing updates. It might be processing packets or access control lists. So the CPU's the brain. It's responsible for doing all those calculations, the computations that need to be done. And well, we also need a motherboard in there as well. Why? Because all those components have to fit together somehow and they have to be able to communicate somehow. So you have a motherboard just like you have in a computer. You have a CPU just like you have in a computer. And you have various types of RAM, or memory, like you'd have in a computer. You can have random access memory, which is volatile. So if the power is lost, you lose everything in RAM. Also, RAM is where everything's going to be happening at that moment in time. So the operating system's running in RAM. The configuration's running in RAM. Everything you execute's running in RAM. However, we also have NVRAM, which is a non-volatile RAM, which is going to preserve any information that is stored within it if there's no power. So we'll use NVRAM as a way to copy our configuration information and have a copy of the running configuration that's in RAM in a backup location. So think of NVRAM as more of a place to locally store backups of information that you have that might be needed during a boot process. So the configuration file is needed during the boot sequence. Therefore, the configuration file should be backed up from RAM into NVRAM in the device. We also have ROM. ROM is a type of memory as well, read-only memory. And again, this is a non-volatile type of memory. But what is contained in ROM? We have features like our Bootstrap that is inside ROM. And Bootstrap is essentially microcode, code that is needed to bring the device up when we turn it on. So I power on my router. How does the router know what to load, what to boot? How does it even know that all the components that we see here externally, these interfaces, are functioning? Well, it's going to have to go through a power on self-test. Then it has to load the operating system. Then it has to load the configuration files. Well, ROM has all the microcode, the commands that are necessary to make all that happen. Then we also have Flash. Flash inside the router. Flash might also be on a compact flash card that we can slide into the device through an external port. But what is Flash going to be used for? Well, Flash allows us to store information in it. It might be our operating system. It might be some extra configuration files that are necessary. It might be some licenses that we have. So Flash is really, you can think about it as a storage location. It's like the hard drive you would have in your computer, but in this case, it's just Flash. There's no room for a hard drive in these routers. So we have Flash memory instead. So the operating system will be stored in Flash. And then when we load the device, the operating system is decompressed and loaded into RAM. So operating system runs in RAM, but it's stored in Flash. Now on the front of our router or on the back of our router, it all depends on how you look at it. There's going to be various ports. We have management ports. Couple of different types of management ports on top of that. So we have a traditional console port, and the traditional console port would be utilized for initial management functions of the device. So you buy the product, you open it up, it's all nice and shiny, there's no scratches on it, you're admiring it. Well, now you want to access it and configure it. So you're going to plug into the console port using a console cable. In this case, we have our RJ45 console port, but a lot of newer devices come with a USB console port as well. So you can access the device for initial management purposes through the console port, the command line interface. Auxiliary port is really there so we could plug in a modem just in case. It's one of those features that a lot of organizations don't use, but you might want to take advantage of it if you ever experience a situation where you cannot access the device through the console port or remotely to manage it. Well, then at least you can call it through the auxiliary port, dial in. Essentially, it'll answer your call and then you can manage it through that auxiliary port. So you're going to plug a modem typically into the auxiliary port. What else do we have here? Management Ethernet port. So what we might want to consider doing is setting up an out-of-band management network. So I'm going to have a switch set up in my wiring closet, my networking room. So we have our switch set up. And that switch is not going to be used for regular data traffic. That switch is going to be used to connect all of my different switches and routers together that we are utilizing in the organization. So they're going to have their Ethernet management port connected to the switch. And that switch is and these management ports are all going to be in the same subnet. And it's just for management purposes. So I'm going to have a computer that's also able to connect to this particular management network. And then I have out-of-band management. So I don't have to worry about my management traffic flowing over the exact same links as the regular data traffic in my organization. So we have this out-of-band management port that we could utilize for management purposes. We also have our network ports. Could be fiber optic ports, could be Ethernet ports using RJ45 connectors, could have serial ports on the device. So depending on the type of router we buy, could have typical copper ports, UTP ports, RJ45 connectors, or fiber optic network ports. So the network ports are used for what purpose? To gain access to the network, so that way there we can transmit the data traffic, voice traffic, and video traffic.